Hey everyone, welcome. Today, we're going to unlock one of the most powerful tools in all of circle geometry, the tangent. And we're not just going to memorize rules, oh no. We're going to build a proper toolkit so you can look at tricky geometry puzzles and just solve them with confidence. So, let's get started. Okay, so take a look at this. I know, at first glance, it looks pretty complicated, right? You've got lines and angles all over the place. But believe it or not, this is the exact kind of problem you'll be able to solve no problem by the end of this explainer. This is our target puzzle. Let's start building our toolkit. First things first. Before we can solve anything, we need to know exactly what we're working with. So let's define the most important term for today and add that very first essential tool to our geometry toolkit. So a tangent, it's just a line that skims the very edge of a circle. It touches it perfectly at exactly one spot. And that special spot, we call it the point of contact. Not 2 points, not 0 points, just one. That's the key. And okay, here's a heads up, because this is a super common place to get tripped up, so let's clear it up right now. A tangent is not the same thing as a secant. Check out the difference. A tangent, over on the left, just gently touches the circle at one point. But a secant, on the right, well, it slices right through it, hitting it at 2 different points. So 1 point, tangent. 2 points, secant. Got it? Awesome. Okay, now for our first major rule. And this isn't a suggestion, it's like a fundamental law of circle geometry. And honestly, it's the key to solving so many problems. Let's see what happens when a radius and a tangent meet. So here's the rule, word for word. What it means is that wherever a tangent touches a circle, the radius that goes from the center to that point of contact will always, and I mean always, form a perfect 90-degree angle. They are perpendicular. It kind of makes sense, right? The radius is the shortest path from the center to the tangent, and the shortest path is always a perpendicular line. So, how does this help with our puzzle? Well, look. See where the radii OP and OQ meet the tangents AP and AQ? Right there, at points P and Q, boom, we have 2 90-degree angles. This is a massive clue. So here's a big exam tip for you. Always be on the lookout for that hidden right angle. It's so often the very first step to finding the solution. Let's grab our next tool. What happens if we have a single point just kind of floating outside the circle? How many tangents can we draw from that one spot? And is there anything special about them? Well, this leads to another incredibly useful rule. Okay, so from any single point outside a circle, like point A in our puzzle, you can draw exactly 2 tangents to that circle. No more, no less. And the really cool part? The lengths of those 2 tangents from the external point to where they touch the circle are always identical. And looking back at our puzzle, this rule is staring us right in the face. We have that external point A, the 2 tangents drawn from it are AP and AQ. So, because of this rule, we now know for a fact that the length of AP is exactly equal to the length of AQ. All right, time for a quick pop quiz. Let's make sure you've got this. If we have a point P outside a circle and the tangent PA is 10 centimeters long, what does that tell you about the length of the other tangent, PB? Yep, you got it. It has to be 10 centimeters. The lengths of tangents from the same external point are always equal. It's simple, it's powerful, and it's really easy to remember. Okay, so we've got our tools, we know what a tangent is, we've got the right angle rule, and we've got the equal length rule. It's time to stop just talking about theory and actually solve some stuff. Let's put these tools to work. So here is a classic problem you might see on an exam. Imagine 2 radii forming a 130-degree angle right at the center of a circle. If you draw tangents at the very ends of those radii, what's the angle going to be where those 2 tangents meet? Let's look at our toolkit. We know the tangent is perpendicular to the radius, so that's a 90-degree angle. And we know a basic geometry fact. All the angles inside a 4-sided shape, a quadrilateral, have to add up to 360 degrees. So which of these is going to help us the most? Go ahead, pause and think about it for a second. Okay, let's break it down together. Step 1, identify the shape, the 2 radii and the 2 tangents. They make a 4-sided shape, a quadrilateral. Step 2, apply our right angle rule. The angles where the tangents meet the radii, they're both 90 degrees. And step 3, just do the math. The total is 360, so we subtract the angles we know. 360 minus the 130 at the center, minus one 90-degree angle minus the other 90-degree angle, and that leaves us with 50 degrees. That's our answer. You've done great so far, seriously. We've defined the tools, we've used them to solve a problem, so let's do a quick recap, and then I'm going to leave you with one final challenge to solve on your own, putting everything we've learned together. Here it is, your tangent cheat sheet. 4 simple rules. Number 1, a tangent touches a circle at just one point. Number 2, it's always at a 90-degree angle to the radius at that point. 3, from any point outside, you can draw 2 tangents. And 4, those 2 tangents are always equal in length. This is your entire toolkit, right here. And now for your final challenge. Look closely at this diagram. If the angle between the 2 tangents, that's angle APB, is 50 degrees, what is the value of that smaller angle inside, OAB? Use the rules from your cheat sheet. You can solve this. Here's a little hint. Think about the types of triangles you can find inside that shape. And remember, no matter how complex a geometry problem looks, it's almost always just a few simple rules wearing a clever disguise. You have the tangent toolkit now. The only question is, what puzzle will you solve next?